This is, sorry, Algebra 2, Section 4.3, Part 2. And on this section, we're going to be focusing on graphing logarithms. And the best way, until you get good at these and really understand them, the easiest way to graph these is to start with the exponential. And because logarithms and exponentials are inverses of each other, then you can reflect the exponential over the line y equals x and get the logarithm. So you can see that here in this figure. If you start with an exponential of y equals 2 to the x, which is this blue curve, and then we have the line y equals x or y equals eggs. If you look at that joke, of course I think I forgot to show you guys that, but anyway, it's one of the little jokes they have. Sounds like y equals x. You can see if you reflect it over, you get the red curve. And let's just go ahead and do that. So we're starting with y equals 3 to the x. That's our exponential. And they've given us the typical x values. So let's go ahead and do those. X, f of x, which is 3 to the x. We're going from -2 and so on and so forth. Plugging -2 in. So 3 to the -2, that's the same as 1 over 3 to the +2, which is 1 over 9. 3 to the -1 is the same as 1 over 3 to the +1, which is the same as 1 over 3. 3 to the 0, anything to the 0 is 1. 3 to the 1 is 1. 3 squared is 9. Okay, we'll throw those on the graph. Ooh, straight line. Actually, don't really have to go that far out on the x's, it's the y's I need. 1, 2, 3, 4, 5, 6, 7, 8. Here's 9, because I know I have to go up to 9. -2 is only 1/9. It's hardly off the axis at all. -1 is a third. It's a little higher up. 0 is 1. 1 is 3. And then 2 is 9. So I'm going to draw this nice, beautiful curve. 3 to the x. You do need to be able to graph those by hand on your own on the quiz coming up. Just make a t-chart and use your exponent rules and come up with your equation. Then, because exponentials and logarithms are inverses of each other, we also know that with the inverses, the x's and the y's are swapped. So that means, new color, we are going to have, this will be x and the new y will be the logarithm. It does say to graph its inverse. It doesn't even talk about logarithm, but it is. And the base is 3, so it's log base 3 of x. Might as well label it correctly, right? So all of the y's from the first function are going to become the x's of the inverse. And all of the x's are going to become the y's. So we just do a quick little swap here, no thinking required. And then we plot those points. So we're going to go over barely a little bit, 1/9, then we have to go down 2. So barely over and down 2. Over a third, down 1. Over 1, 0. 3, 1. And 9, 2. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, this is 9. 9, 2. And we're going to draw that smooth curve. Now when you draw it, oh, by the way, did we talk about the asymptotes on the exponentials? I hope we did. The asymptote of this exponential, I don't know if green's going to look very good, but we'll do it anyway. Or orange rather. Here's the asymptote of the exponential. So if you reflect that over the line y equals x, that's going to be the new asymptote, or the asymptote of the logarithm. So when you reflect that over the line y equals x, you're going to get x equals 0. So that's the asymptote of the blue curve. So when I go to draw my blue curve in, I can see these are getting closer and closer. They're not going to cross that line. So this is the logarithm of base 3 of x. And then I like to use black for some reason for my y equals x. Oops, didn't work out so well. That's y equals x. Visually, these need to be reflections over that line. And we're not done yet. We have to describe the domain and range of the inverse function. So, well, that's not too bad, I guess. The domain and range of the inverse is the domain and range of the logarithm. So the inverse is log base 3 of x. So we're describing log base 3 of x. We're going to describe its domain and its range. Domain are the x's. If you look at the blue curve, what's the smallest x? Well, it's never going to get past this orange asymptote here. So that means that, is it ever going to reach the asymptote? Is it ever going to get to there? No. So it's never going to reach 0. That means, but it's going to approach 0. So 0 is going to be our initial x, but because it doesn't actually reach it, we need a parenthesis. And then the largest x, well, it goes forever that way to the right, so it's going to be infinity. The range, those are the y's. This blue curve is heading down, 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 down to negative infinity. That's the smallest y. It's also, on the other end, heading up. Now, it looks really flat. Do you think it flattens off? No, actually it doesn't. It keeps going up ever so gradually, but forever. Forever upward to infinity, believe it or not. It's going to take a long time to get there. If it keep on going forever, it's going to get forever big. And there you have your domain and your range for a logarithm. Okay, you could try this one on your own, and then I will be doing it. So it's the same type of problem. xy, in this case is 0.8x. We'll go, oh, this time we're using different x's, alrighty then. Negative 3, 0, 1, 4, and 7. So 0.8 to the negative 3. I'm going to use my calculator for that one. We've got 0.8 raised to the negative 3. That is about 1.95. 0.8 to the 0, that's 1. 0.8 to the 1 is 0.8. 0.8 to the 4th, I need to go back to my calculator. I don't know what that is off the top of my head. 0.4096. And 0.8 to the 7th. Back to the calculator. And we've got 0.21. About. Great. Now let's graph that. We've got some pretty small numbers we're dealing with. Interesting. Okay, we've got the point negative 3, 1, 2, 3, and up about almost 2. 0, 1. 1, 0.8, it's about there. 4, 1, 2, 3, here's 4. 4 is about a little lower than a half. And then 5, 6, 7, again, I'm at the right spot. 0.21, so it's about down there. So this is a decaying curve. It's taking its time, slowly decaying, and that's the original one. Okay, it's time to do the logarithm. Let's change colors. Logarithm, that's going to be log base 0.8 of x. And we're going to switch those y's and x's. So all the y's become the new x's. I'm going to write 0.41. And then all the x's become the new y's. I don't know why they chose those points, but it works. Okay, plot those. So we're going to go over about 2, a little less than 2, and down 3. We're going to go over 1, 0. We're going to go over 0.8 and up 1. We're going to go over a little less than half and up 4. 1, 2, 3, 4. And we're going to go over 0.2 and up 7. 1, 2, 3, 4, 5, 6, here's 7. And we're going to connect those with a smooth curve. That's log base 0.8 of x. Doesn't look anything like the other one. But these do look like reflections across the line y equals x. And we do know that the exponential, since it had a base of 0.8, that is a decay function, and this original exponential is going down. So it's looking reasonable. And then finally, we need to do the domain and range of the inverse. So the inverse is log base 0.8 of x. The domain are the x's. Okay, the smallest x on that purple curve. It looks like, again, here's the asymptote, that vertical line. It's approaching 0 but never reaching it. So starting at 0 but non-inclusive. It's going this way. So the largest x, if you follow this thing out, it's going to go on and on and on to infinity. A range. Smallest y value, it's going all the way down, 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 down to a negative infinity. Greatest y value, it's going up, 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 up to positive infinity. And onward. Oh my, a whole nother one. Gosh, I don't want these tapes get long. It's the same idea. I think I might skip it because we've seen 2 of these now. And 2 to the x is going to be very similar to 3 to the x. It's the same problem. If you want to do it on your own, that would be great. I wonder if it's in the book and you could check yourself. If you want extra practice, let me just take a quick look. This one is not in the book. Actually, it's not in there at all. I think I made it up. That's okay. I'm going to skip it. We just don't have time. It takes too long to record these videos. Okay. Environmental. So this is our last one. This one's actually really fun. And if you guys are in any chemistry classes, you will probably use this equation. Chemists regularly test rain samples to determine the acidity of the rain. And it's based on the concentration of hydrogen ions, the H+. Acidity is measured in pH from like 0 to 14. And if you study that, you know that 7 is neutral. And I believe the low ones are acidic, the high ones are basic. And here's the formula right here. This is the important part. So I'm going to write that down. They don't give us much work room. pH is equal to negative log of the hydrogen ion concentration in moles per liter. So that's your units for your H+. Find the pH of rainwater from each location. So Central New Jersey, if I look on the map, is right here. That's my hydrogen ion concentration. So the pH is equal to negative log of that number. We've got 4 zeros there. 316. And it's in the correct units, moles per liter, so that's good. Okay, this is not something you're going to do in your head. We don't know what 10 to what power, because this is base 10, by the way, because it's not stated, so it's understood to be base 10. It's not going to be something I can do in my head. But we can do it on the calculator. So, a new key we have not used before is logarithm. And you can see over here on the left, there's the log button. So because this is negative, I'm going to do negative first. Then I'm going to press the log button. That log button is understood. That is the common log. So that's base 10. Point, and then we'll put it in. 1, 2, 3, 4, 3, 1, 6. Enter. We have an acidity, or pH rather, of 4.5. So the pH on this one is 4.5. Try the second one on your own before you watch the tape. Okay, pH is negative log of North Dakota. Point. 1, 2, 3, 4, 5, 6. 6 zeros. 1, 2, 3, 4, 5, 6, 9. Calculator. Whoopsie. Okay, I'll get this out of the way so you can see things. Negative log of point. How many did I say there were? 6? 1, 2, 3, 4, 5, 6, and then a 9. Enter, and we get pH of 6. That's less acidic than Central New Jersey, which should make sense because I believe probably over in New Jersey there's a lot more pollution, more population, probably maybe some more industry. I've never been there. I wonder what Alaska's is. So if you wanted to, you could go online and find out what the hydrogen ion concentration for Alaska is, and you could figure out what the pH of our rainwater is. Okay, that's great. We're done.